This video will review factoring of binomials, and in particular, use that factoring of binomials and the zero product property to solve quadratic equations, particular types of quadratic equations. Use the square root property to solve quadratic equations, as well as to use completing the square along with the square root property to solve quadratic equations. First, let's take a look at reviewing factoring of binomials. What we found out is that if we wanted to factor something that looked like a squared plus b squared, then we knew that the factored form was prime and that we could not factor it. But now that we know a little bit more about complex numbers and stuff, we're actually going to find out that we can factor it into a plus bi and a minus bi. These are the complex conjugates. And we'll talk a little bit more about that in a second. But we also know that we can factor a squared minus b squared into the form of a plus b times a minus b. Again, these are conjugates, just not complex. So now let's do an example of factoring difference of squares. Let's say we have 16x squared minus 49. Well, what we do know is that we could imagine that this 16x squared as something squared and that 49 as something squared as well. So we can do that. We're going to see that 4 squared is 16 and 4x squared is going to be 16x squared. And 7x squared is equal to 49. Remember, this is our a value and this is our v value. Those things that are inside the parentheses. So our factored form would be thinking it as a plus b and a minus b. So if we do our factors, we're going to see that we're going to have 4x and 4x, which makes sense because when we're multiplying 4x times 4x, we're going to get our 16x squared. And our b is going to be 7. That makes sense as well, because if we're going to multiply 7 times 7, we're going to get our 49. So now we see that we need one of them to be plus and one of them to be minus. The reasoning behind that is because we want, when we finish multiplying on the inside, we're going to get 28x. And when we multiply the outside numbers, we're going to get negative 28x. And when I add those up together, we get 0 or nothing. And that's the reason why we don't see it in our quadratic equation that we have here. So we have completed the factored form of that. The other thing we're going to do is talk about what if we're going to solve. So let's say we have example number 2 that says 16x squared minus 49 is equal to 0. So notice we have the exact same thing that we have up here in example number 1, except this one is set to equal to 0. So let's go on ahead and factor. In fact, we already know the answers to our factored form. That's going to be 4x plus 7 times 4x minus 7. And it's still equal to 0. Notice we just use our factored form that we found up here. Now that it's equal to 0, we're going to talk about the zero product property. So the zero product property states this. It says that if you have a product, that means you're multiplying two things. We'll call that A times B, or whatever two letters you want to use. If we multiply them, the answer is what we call the product. And if it's 0, this is why this is called the zero product property, it says if you have these two things being multiplied and they equal to 0, then one of them has to equal to 0. I don't know which one, maybe both of them do, but at least one of them has to be 0. So we're going to use this thought so that we can solve our problem over here. So using the zero product property, if I kind of think of this as my A version of being multiplied and this as my B version of being multiplied, then we can sit there and say that 4x plus 7 is equal to 0. or 4x minus 7 is equal to 0. Then we have two linear equations that we need to solve, so we're just going to solve them by subtracting 7 to both sides. And then we'll get 4x on the left, and on the right we'll get negative 7. We're going to divide both sides by 4, divide both sides by 4, and we're going to find that x is equal to negative 7 over 4. We're going to do the same thing on the other equation. We're going to add 7 to both sides, and we're going to find that we get 4x is equal to 7. We're going to divide both sides by 4, and we're going to find that x can equal to positive 7 over 4. So our solution set for this equation is two answers, negative 7 over 4 and positive 7 over 4. So I want to go back to our example number 2 here. I'm going to call it example number 2b. It's the same problem. We have 16x squared minus 49 is equal to 0. I wanted to show you a different way of solving this particular problem. What I'm going to do is start to get x squared by itself. So I'm going to add 49 to both sides. And we see that we have 16x squared is equal to 49. And I'm going to divide both sides by 16. So notice we're doing fine. We can do all these things. We're going to get x squared is equal to 49 over 16. And all we have to do now is solve for x. Well, we can use what we call the square root property. And what the square root property says is this. If you have x squared is equal to some number, then you can take the square root of both sides. But remember, it could be positive or negative, and then it will be the square root of that number. So just to give you a quick example, if we had x squared is equal to 25, we can take the square root on the left side and the square root on the right side. On the left side, the square root and the square undo each other. And on the right side, I got to remember to put that plus or minus and then do the square root of 25, which is 5. So this says that you can actually have an answer of 5 as well as an answer of negative 5. That makes sense because if I squared both sides, we can see that we would have x squared is equal to 25, which is what we said originally. On this side, if we square everything on both sides, we would get x squared is equal to 25 again, because negative 5 times a negative 5 equals to a positive 25. So it's working. What does that mean for our problem? That means that we can take the square root of both sides. So that means we end up with x on the left side because the square root and the square undo each other. And on the right side, I got to remember my plus or minus. And from our notes about radicals, we know that this is the same thing as the square root of 49 over the square root of 16. So working it out further, don't forget your plus or minus. The square root of 49 is 7 over the square root of 16, which is 4. So this means that we have a solution set with two answers. One of them is 7 over 4, and the other one is negative 7 over 4, which we see is the same thing that we found up above. Now the cool thing about square root property is that we don't have to remember how to factor stuff that doesn't work. So moving on to example number 3, let's say we have something that looks like x squared plus 36. And we say that's equal to 0. So again, we can try factoring and realize we can't factor in our traditional style. But what we can do is we can subtract 36 to both sides. And we're going to get x squared, the 36 became 0. And on the other side, I have a negative 36. We can use our square root property that says take the square root on the left, take the square root on the right. But don't forget, you're going to get x on the left, and you're going to get plus or minus the square root of negative 36 on the right side. We can simplify this. Good thing we took notes about how to take the square root of a negative number, and we're going to find that our x is equal to a positive or a negative 6i. Don't forget, we can rewrite this as the square root of negative 1 times the square root of 36. That's where that I came from, and the square root of 36 is 6. So what this says, we have two answers. One of them is positive 6i, and the other one is negative 6i. Now remember what we did at the very beginning. We kind of mentioned that, yeah, we could factor x squared plus 36. By thinking of it as complex numbers, we would have like x and 6i and 6i, and one of them positive and one of them negative. These would be our complex conjugates. We can do FOIL real quick just to see if this is true. We would get x squared. We would get 6xi and minus 6xi, so those cancel away. And then the last thing I would have, we would get 6i times a negative 6i. And then when we multiply, I'm going to get a negative. 6 times 6 is 36. I times I is I squared. But don't forget that I squared is the same thing as negative 1. So negative 1 times a negative 36 is a positive 36. So it's working, and that's how we would get x squared and the positive 36. So then we can use the zero product property and say, okay, well, since these two guys multiply and equal to 0, then x plus 6i can equal to 0, or x minus 6i can equal to 0. And then I can start solving my normal way. Subtract 6i to both sides, I get negative 6i, so we're getting this answer. And if I add both sides 6i, I get x is equal to a positive 6i, and I get my other value. So factoring still works. The only problem is that before we've always considered these guys prime because we could not factor into integers. In this case, we're factoring into complex numbers. Let's say we try another example where we have x minus 4 squared is equal to 15. Okay, well, we still kind of have the same format as our square root property that says you have something squared is equal to a number. Then you can take the square root of both sides, but don't forget plus or minus on the right. So we're going to do the same thing. We're going to take the square root of both sides. We're not going to forget our plus or minus on the right side. Over here, our square root and our square cancel, and I get x minus 4. And I still have to figure out the square root of 15. Well, let's take a quick look at the square root of 15. The only factors I know for 15 are 5 and 3. And neither one of them is a perfect square, so we cannot simplify the square root of 15. It stays as the square root of 15. We still have to solve for x, so I'm going to add 4 to both sides. So notice on the left side, I just get x, which is what we were looking for, so good job. On the other side, I have a whole number being added to a radical. So I'm going to put that whole number in the front. I still have that plus or minus the square root of 15. So I can still add or subtract the square root of 15. This will give me my two solutions. One solution would be 4 plus the square root of 15, and the other one would be 4 minus the square root of 15. So I wanted you to see that even if we had something that had squared, and it wasn't quite just x squared, but x plus a number or minus a number, it didn't matter, and is equal to a number, we can actually take the square root of both sides.